This talk centers around soil testing, how they're done, how they can help you make management decisions regarding soil fertility. So do you need to test your soil? And the unequivocal answer to this question is yes. Soil tests are the basis for proper nutrient management and optimal yields, and you need to do this in order to make sound management decisions regarding soil fertility. Now, I don't begrudge anybody trying to save some money, but the kit that you see here is at best suited to hobby growers. You are business people and you need a little bit more finesse than what this kind of a testing kit can provide. So the first thing you should do is find a certified lab near you. I found that the Illinois Soil Testing Association can be quite helpful. These are certified labs that meet standards by the organization and have passed tests, noting them as a valuable and accurate laboratory to send your samples to. The URL there will give you a list of labs. Anybody on that list to be fine to use for soil testing. This table shows a rating of the reliability of soil tests and how useful they are. Of course, the pH test is 100% useful and repeatable, reliable, useful, cost effective, etc. On and on. These tests can span quite a bit of range. Ones in the lower brackets, you could take the same sample, test it 10 times, and get 10 different numbers. So be advised when you're testing that it's not a concrete number in all cases. Take it with a grain of salt. Even the best lab is only as good as the best methodologies, and some of them aren't that good. Several ways to take a sample: soil probes, augers, shovels, spades, just however you can get the sample out of the ground. Generally, a lab that you're going to send a sample to is going to have guidelines: how deep, how many, etc., etc. If they can't tell you this, I would find a different lab. Any certified soil testing lab will have procedural advice in place to tell you what to do. This is a diagram of how to collect soil samples from a 40-acre field. This is not the way it's normally done. I would advise taking as many as you can humanly take, but the example on the right, while I give them points for trying to for completeness, this is not it's not realistic to take that many samples. Do what you can. If you have known areas of difference, separate the samples out. Don't composite them so you have a sandy soil on half your land and a beautiful silt loam on the rest. You can tell there's differences visually. Take samples from each and divide things up. That is the key. Nutrient availability is controlled by soil pH. You can see here that for most nutrients, the sweet spot is in the area of 6.5 on the pH scale. So this is the pH that you would like your soil to be at, and if it's not around this range, you would like to adjust. So how do you take a pH measurement? You may have some interest in how this is done. The pH scale goes from 0 to 14. Basically from battery acid to lye. pH measurements of your soil, this is the first thing you should do because it controls nutrient availability. There's some low-tech reactive dye techniques, pH papers, pH meter is more often than not the way a laboratory is going to do this. It's a one-to-one paste, generally made with water. You measure it after a short attenuation period. Downside of this is good meters aren't cheap, and you're probably not going to have to take a lot of pH readings, enough to justify the cost of buying a decent pH meter. Again, what is optimal? 6 to 6.5. And this is ideal if the crop is an acid loving. Be advised that certain crops have requirements outside of this range, such as blueberries, for example. So what if my pH is too high? This means basic. Well, you must lower it. So here's an example of how many tons of sulfur you need per acre to lower to 6.5. Are there other pH adjusting compounds? Yes. Aluminum sulfate, peat can be tilled in. In general, sulfur is going to be the cheapest and most effective way to get this done in a short amount of time. So again, granular sulfur is the cheapest and most readily available acidifying agent out of many. It takes a while to adjust soil pH. The soils tend to be resistant to change. Sandy soils react a little bit quicker, so you need to decrease the application rate lest you acidify too much. And clays, the same to a certain extent. The same thing applies. Decrease your application rate by half. By no means apply 1 to 2 pounds of sulfur per 100 square feet for application. Oftentimes this might be lower than what you're supposed to apply in totality to reach the 6.5. You might have to take steps to get to where you're going to make the full application. So wait at least 3 months between applications, and 3 months again if you have to make an. Oftentimes your pH is going to be too low. This happens because of a variety of factors, but more often than not it's because you use some sort of nitrogen fertilizer. They tend to acidify the soil. So lime requirements are dependent on how much the textural classification of your soil. And here's a chart, for example, that shows how many tons of finely ground limestone to apply per acre. Finely ground here is the key because the finer the grind, the quicker the reaction of the limestone in raising the pH. So here's a last thought on pH adjustment. If you do wind up sending your sample to a reputable lab, they often generate a report. This is a soil analysis report that you can see, for example, here. It's actually a company in Illinois. They will often, along with the actual values that they have obtained for your soil sample in terms of potassium, phosphorus, calcium, CEC, and in this case pH, they will generate a report to say how much limestone you will need or how much sulfur you might need and per area to adjust. In this case, if you look at the pH values, you would not add anything to any of the areas, the west plot, center plot, top plot, or creek bottom, because these are in an acceptable range for the test. Moving on to soil phosphorus. This is a generalized map of phosphorus supplying power of soils in Illinois. We have, and realize this is generalized, but it gives you a good idea of where the high values, medium values, and the low values. Phosphorus testing, there are several accepted methods. Probably the most popular would be the Bray-Kurtz P1, developed in 1945. It's an extraction method using dilute acid. Another version would be the Olson method. Melick 2 is probably the second in popularity compared to Bray-Kurtz. It's another extraction method, uses a lot of extractants, developed in 1984. The key word here is extractant. The extract of the soil is then run through a machine, the phosphorus content determined by flame photometry, inductively coupled plasma atomic absorption spectroscopy, colorimetrically, etc. You arrive at this results in a fertilization guideline based on your test value, the type of crop you're trying to grow, and the estimates of the crop removal of phosphorus from your soil. The Midwest Growers Guide recommends that crops cultivated on mineral soils will benefit from added phosphorus if the test is less than 35 to 40 parts per million Bray P1, and mineral soils greater than 80, no additional phosphorus is recommended. University of Kentucky and Tennessee have conducted research to give actual rate recommendations. Your test is low. How much phosphate is P2O5 required? We give the whole rate, and again, over 80, nothing is recommended. So a sort of sliding scale there. Soil potassium. This is a generalized map of Illinois showing areas of high and low values. Green areas are sandy soils with very low CEC test values, and therefore, since CEC corresponds with K supply, they have very, very low potassium supplying power. Again, we extract the soil. In this case, Melic 3 is a common extractant. Again, the extract can be measured by ICP, flame photometer, what have you. Recommendation. Potassium recommendations are based on the soil test value, your CEC, the crop you're growing, and again, estimates of crop removal of potassium. Midwest Growers Guide recommends vegetables usually benefit from fertilization if the test is less than 85 on a soil with a low CEC, less than 115 on a soil with a medium CEC. The maximum recommendation is 300 pounds K2O per acre. Potassium fertilizer is not recommended if the test is greater than 135 on a soil with low CEC or greater than 165 on a soil with medium CEC. The higher CEC, the more potassium you can hold on the exchange sites, therefore that's why that number is high. Again, research in Kentucky and Tennessee give recommendations. In this case, above 450, they say don't add any, and their cutoff in terms of low is a 201 test result, corresponding to 121 to 250 pounds of potash per acre. So why is soil testing important for specialty crop producers? Well, I would say it's important for all producers, but specialty crops in some cases require specialized treatment. Otherwise, they wouldn't be called specialty crops. This can be traced, this idea, back to Justus von Liebig's law of the minimum, which is typically shown as this barrel with corresponding staves of different heights. And each stave corresponds to a particular essential nutrient that the plant needs. And basically what this illustrates is that that plant growth is controlled not by the total amount of resources available to the plant, but by the scarcest one. So it's the one that is scarcest that limits the potential yield of the plant. Some problems that are commonly found in specialty crops: phosphorus scores can be too high. This basically comes out of, I believe, triple 10 or triple 15 fertilizer. You could grow a lot with that, and it was looked at as a pretty easy way to cover all your bets for a number of years. But as the phosphorus kept getting dumped into the soil, test scores went sky high, and particularly for vegetable culture. This has led to some problems in nutrients and nutrient availability, as well as environmental pollution. There's a lot of advising when you get an imbalance in the system to begin foliar feeding. A lot of times there's something wrong with the root system or something physiological, and it's bringing about the said nutrient problem. So it pays to dig a little deeper rather than just assume you have a nutrient problem. Maybe send things out to the disease lab. And a lot of over fertilization or nutrient deficiencies, to complicate matters, are often seen as diseases. In fact, in some cases, such as with nitrogen applications, too much nitrogen can make the plant so succulent that it is incredibly tasty to disease organisms and insects. So anything out of balance will really can throw off the system. Other differences between traditional crops and specialty crops: the fertilizer materials used, typically in a row crop agriculture, anhydrous ammonia, maybe some lime, potash, and some phosphate thrown in for good measure. These are put on before the crop is sown, worked in. Specialty crops, generally you put down, in the case say of tomatoes, half your nitrogen if you're going to fertigate, and then dose the rest out in sequence over the rest of the growing season. This is not the way that cash grain is treated. Methodologies are a little bit different. A lot of vegetables are grown on plasticulture. That's quite a bit of a step in a different direction compared to open fields of grain corn and soybean culture. And fertilizer expenses are normally not the most significant overall cost of production. Most of the time in vegetables, I would argue that labor might be your limiting factor there. And then again, this goes back to excess fertilizer may result in problems beyond simple waste of money. You may have a big problem on your hand and perhaps have to let the land lay fallow or put it into a cover crop if it's been extremely mismanaged. So there are the tools in addition to soil testing used by specialty crop producers. These could be evidenced in tissue analysis, sap testing, visual inspection. I think you should be doing that anyway. In fact, most farmers do that. Some people rely on downloaded feeding schedules from the internet or other publications. Standard tests for nitrogen aren't available at the present to predict how much nitrogen a vegetable crop will need. So fertilizer nitrogen requirements are affected by experience of the grower. I mean, you learn to know your land, but on-farm trials, fertility trials, particularly for nitrogen, can help optimize how much you would use in a normal year, quote unquote. Soil type definitely affects how much nitrogen you're going to need. A poor sandy soil will require more nitrogen to get the same yield as compared to a nice black dirt, if you will. The cropping history of the site: you'll need less if it's coming out of sod than if it was in constant continuous corn for 30 years. More organic matter, you have more cation exchange capacity, more holding capacity for nutrients in the system, and the crop culture system you're using. So there's no perfect end test yet. There are some tests that people use. Soil nitrate N prior to pre-plant or prior to side dressing. Development at the university a few years ago was the Illinois Soil Nitrogen Test, or ISNT. but this still needs some research and development to determine if it will be useful to specialty growers in the future. There's a lot of controversy surrounding the test and whether or not it works in cash grain. It remains to be seen if there's some value for specialty growers. And then soil incubations followed by an analysis. You can look at nitrate production over time. This can give you an idea of how much nitrogen your soil will mineralize in a so-called ideal situation. So there are nitrogen fertilization recommendations for tomatoes. As I said, following grass, legume, or legume sod rotation, you need quite a bit less than continually cropped land. Here's a sap tester. There's a lot of guidelines that go on how to take particular samples for particular crops. This test can be performed with a simple garlic press. You put the petiole or whatever part that you are supposed to be testing according to the guidelines into the garlic press, and you can extrude quite a bit of sap. Post-extrusion handling of the sap is critical, and it's outlined pretty clearly what you need to do. You should probably look at that URL if you're thinking about getting into this. Fertigation. Fertigation is basically applying your fertilizer along with your irrigation water. So basically you put on a small amount of fertilizer pre-plant, and the remaining nitrogen will be divided into equal amounts on a weekly basis. The amount of nitrogen depends on the nitrogen analysis of the fertilizer. As you can see, it takes quite a bit less ammonium nitrate than calcium nitrate due to the higher N analysis of the ammonium nitrate versus that of calcium. So some final thoughts on soil testing. Once again, I'd like to stress that on-farm tests can assist in optimizing a fertility program for your farm. Additionally, know who your extension agents are and get to know them. Chances are they've been around the block a few times and they know what they're talking about. They can help you. Additionally, I'd like to stress the point that soil testing isn't something you do once. You repeat your soil tests every 3 to 4 years, or maybe even every 3 years, just to see how you're doing. Because as you put these inputs into your land, things will change, and you have to realize that you have to keep up with those changes, and the way to do that is soil testing. So please repeat your soil tests.